like to start from explaining the system configuration of the system. Basically, it comprises of a web camera that captures the image of measurement object. Also, we have a control PC with the software. We have a spectrum analyzer. I have here the Tektronix model of RSA306B. Optionally, you may use a preamplifier. We have a measurement sensor, electric field probe, and magnetic field probes here. They are used for scanning your EUT with electrical and magnetic fields areas. So also we recommend attaching a special cover on the probes. We have different colors, 3 colors of yellow, red, and blue. So you can choose a color that is different from the color of your EUT. So the web camera can differentiate the probe and the EUT. So first we would like to check our spectrum analyzer settings. Like I have mentioned, we have a spectrum analyzer of Tektronix RSA306B compact spectrum analyzer with a range of 9 kilohertz up to 6.2 gigahertz. So first we start the software for the spectrum analyzer, and we check the starting frequency. We start from 100 kilohertz and stopping up to 3 gigahertz. With reference level, we set 137 decibels for the starters. And so now, as long as we have these settings, we can go to our software EPS. So first we would need to go to the settings and do the image recognition settings here. So if your PC has several cameras, you would need to choose the device, the particular camera which is looking at your EUT. And then you take your probe, and you can see, check that the probe is recognized by the system. If it's not recognized, you have to click on your probe, and then you can see that the image on the left and on the right are moving in the same way. You need to make sure that the cover head of your probe is of different color than the background of your EUT, so that the camera can recognize your probe movement, and it can connect it to a certain location on your EUT. You might want to do the settings of hue saturations and other settings of your web camera, like brightness, contrast, etc. You can also use zoom on your camera to choose the best image to do the scan of your EUT. So as soon as you're ready with your image recognition settings, you might want to go to communication settings, just like here in the Go Set. You need to set up your equipment, meaning the spectrum analyzer. So in an equipment name, you choose your spectrum analyzer here. You choose interface. That may be a LAN, that may be USB, or others. And some models have a serial number, and some models may require you to input the IP address. So you need to choose these 3 settings to connect your spectrum analyzer to the system. It opens the new measurement window. We can see here the web camera is looking at our EUT. We need to mention that you have to do the setting so that the camera is looking at your EUT to do the measurement. So your room has to be bright enough for the light to recognize the probe to see the EUT. If the USB camera is not connected, you cannot start a new measurement. So as long as you have web camera connected and USB key connected, which is your license key, so then you can start your measurement. First, we would like to go to the condition tab and set our conditions. And the first would be image division size. So it all depends on your EUT. We have the large image division. So you can see the boxes here, 160 pixel, and the smallest would be 10 pixel. If you would like to do a precise scanning, so you can choose from 160, 80, 40, 32 or 20 or 16 pixel, and the smallest would be 10. I think we go 20 pixel for this particular EUT of ours. Now we would like to do the setting of capturing. Here we have four modes of how to store spectrum data, and we can choose from these four, and the first would be single. In that case, the system performs a measurement only one time, a single run. We also have free run mode. In that case, the measurement will be always overwritten. So this is overwrite mode. And the third, we have a max peak data. So this mode compares the maximum values of the spectrum waveforms. And then it overwrites if the value is not the largest. And the last one, we have maximum hold. It compares the maximum values of waveforms on a point basis and overwrites the values if they're not the largest. So for today, our demonstration, we would like to do this scan in max hold mode. Now about density display. Selecting create density display here, it generates data required for density display during measurement. So it represents signals in colors. So on the graph, the warmer the color, the more frequently signal appears, and the cooler the color, the less frequently it appears on your scanning. Next, in the capturing section of our settings, we have an option of free run simultaneous display. So when you choose the capturing mode of max peak data or max hold, only for these two modes you can choose also the free run simultaneous display. So it lets you see the peak data and also the current data simultaneously. So in that case, the free run waveform will be in blue color, and your, for example, max hold settings values will be in the yellow color, so you can see them differently. And now about the frequency settings. Basically, the measurement frequency range depends on your spectrum analyzer. It depends on your field probes. And you can choose the settings here from hertz, kilohertz, megahertz, and gigahertz. Do the settings here. So we will try to do here the settings starting from 1 megahertz and up to 3 gigahertz. Now the settings for spectrum analyzer. We need to push the set button, Make sure that the spectrum analyzer shown is the same with our equipment that we have. And then we need to set each parameter for the resolution bandwidth, video bandwidth, attenuator, reference level, detector level, sweep points, etc. So this property box, the contents of this box depends on your spectrum analyzer, on the model of your spectrum analyzer. Now the last section for this tab of condition tab, we have the antenna factor. So when using antenna factor, you need to check the enable factor option here and select the file with the same name as electromagnetic field measurement sensor that you have. So in the initial state after installation, this is the only available antenna factor. Afterwards, you can choose the files that you have the factor in the factor folder. So also the factor files for the electromagnetic field probes that are included with our EPS system are also included on the attached setup media, so it comes together with your setup. We would like to start our actual measurement, and to do that we push the start button here, and now we're ready to do the measurement. We have prepared our measurement probes, so we are ready to do the scan. So be sure to slowly get close to your EUT. So there are some cases when the noise signal is very high. So if noise signal is very high, you can damage your spectrum analyzer or your preamplifier. So be sure to slowly approach the EUT while checking the parameters of the noise that you're receiving. So we're good at this moment, so we do the checking, we do the scanning. You can see we are receiving the waveforms from the spectrum analyzer. At the bottom we are reading the color appears on the map, on the image map. So each dot represents the noise level received through this probe, and the color you can see that the color here on the software image shows the level of decibel microvolt and the noise level here. So each color represents this particular noise range. So we continue our scan. Make sure to make the scan slowly, not to rush it. And if you're using a directional probe like this, be sure to keep it in the same direction and parallel to the surface. But now in this particular scan we're using a non-directional probe, so not relevant to this one. So we make sure to scan all the area. Take your time. You may want to do the scan using different probes. Different probes has different frequency characteristics. Some are suitable for low frequency, and some are suitable to high frequencies. You may try using electrical probes and then magnetic probes to choose which is more appropriate for your noise condition. During the reading, you can access the auxiliary menu here, and you can do the setting of left click operation. You can set the left click operation to delete or to click measurement, and also you can choose image division line to show it or hide it. So previously it was hidden. Now if we choose to show the image division line, you can see this graphs here. And the left click operation set to delete. So if I click any particular cell here, left click, so I can delete it. So some areas which are not meant to be measured, you can delete them. Also, there's a function of highlight unmeasured area. So we right click on our screen and we choose to highlight unmeasured area. So you can easily understand which areas you have missed. So you can go and do the scan again. Just like this. To cover the unmeasured areas. So after we have completed our measurement, we can see that there's a square point displayed on the camera image right here. So this square point automatically moves to the highest level point after we complete the measurement. So we can see that it shows the marker of 2.4 gigahertz with the level of 78.24 decibel microvolts. And we can drag this pointer to different locations to see the spectrum data on each location, just like this. For each location, for example, for this one, we can see that 952.57 megahertz with the volume of 60 decibel microvolts right here. And just like this, we can check any desired location on the map to check each spectrum data, spectrum level. Also, if we go in this state on the condition tab, we can check the conditions that we have conducted the measurement with. So we can see the start, we started from 100 kilohertz until 3 gigahertz with capturing of max hold, creating density display here, and also free run simultaneous display, and our spectrum analyzer data here. So having checked our condition on the condition tab, then we can go to map view, and we can see here that there are some options that we can choose from. For example, the auto distribution. If this auto distribution is checked, then the color map is compiled according to automatic distribution between the highest and lowest intensities. However, we can go to the setting and we can choose to set the upper and lower values to desired values, and we can set these decibel microvolt levels to whichever we desire, and the map will change accordingly to our set values. Also, we can see that there is the interpolation option in the intensity distribution here. For example, if I do the interpolation here, we can see that the map data image is being smoothly displayed with interpolating the boundaries between each single division. Also, we have an option of transmittance, which is basically the transparency of our data. And going left, we can see that transparency is 0, and going up, we can set the transparency so we can see our EUT and the actual part, each single part, which is hidden behind our color image. We also can do the image inversion, vertical and horizontal. So for example, if you start the the testing. So before you start the testing, you can check your image in the camera. So if you see that your EUT and the image in the software are different, or you can change this vertical and horizontal inversion to make your measurement easier. So going to the Graph View tab, we can see that we can choose a specified frequency option, and we can go to settings and choose the starting and end frequency range which we would like to make analysis on. We can do here the settings. Also we can enlarge the specified range just like this. The same thing can be done with level range with the specified level. You can see here we also can do the settings from lower value of decibel microvolts and the highest upper level of decibel microvolts. We can set those parameters and analyze in that specific range. Also, we can choose switch the unit from decibel microvolt to decibel meter, and frequency axis switch from linear to logarithmic, just like here. We can also go to comment section and input information such as model number, serial number. We can set the date, we can set the temperature, humidity, and any other memo we would like to add to our measurement file. Okay, now I would like to explain about the display data comparison function that we have. We can do the comparison before and after the improvement. So for example, if first we do the scan, initial scan, we find some noise source, we do some improvement on our EUT, and then we do the scan after the improvement, and we want to compare the before and after images. So basically we go to our map view tab here and display data comparison section over here. We choose here to load the this is a before a file before the improvement for file, so I download it here. So now since we have the file the comparison file loaded successfully, and we can see 4 options of target data, comparison data, right, and the target comparison data, and the comparison target data, 4 options. So first one, the target data, is the current measurement, the last measurement that we have done, that we currently have. And the comparison data is the data that we have loaded here. In our case, that would be the before the improvement data. Now we go to the target comparison data. So for this one, for each image division, the difference between the peak of the target measurement data and the peak of the comparison data is calculated here and color coded. The fourth option is comparison to target data. So for each image division, a difference between the peak of the comparison data and the peak of the target measurement data is calculated and color coded here. So for sections where the division showing level increase are displayed in red, and sections showed in blue showing the decrease in level, and where there has been no difference, it shows in white section. So we can also choose the method for comparison, either decibels or microvolts. So this is the useful tool to compare the data, the two scan measurements that you have, initial measurement and the measurement after you have conducted some improvement to your, for example, PCB design or to your EUT.